Hello, this is Mr. Messman's vodcast for Chemistry of Earth number 6. I can build models of molecules of any molecular formula. So let me take you through the concept of molecules and covalent bonds. So I'm going to work with two atoms, carbon and oxygen. Okay, carbon from group 4 has 4 valence electrons, outer shell. Oxygen from group 6 has, you guessed it, 6. Write them like this if we want. So carbon is in a strange place in the periodic table, being in the middle between the metals over here and the non-metals over here. So carbon doesn't tend to lose or gain electrons to become an ion. It tends to share. Okay, and that's the key to covalent bonds, sharing electrons. So they still have to have 8 to be complete. Both of these elements want to become like neon over here with its 8 outer shell electrons. So there's actually a couple ways that carbon and oxygen can get together and do that. Well, since carbon has 4 available, oxygen has 6, carbon would need 4 more, oxygen would only need 2 more. So here's one way that they go about doing that in what we call CO2, or carbon dioxide. So if I draw CO2 like this, oxygen, carbon, and oxygen, what we end up with is shared electrons in between the carbon and the oxygen. And we end up with unshared electrons out here on the outside of the oxygen. And the way I usually like to draw this is with a circle that surrounds the carbons. I don't know if this is going to work. It's not too bad. If I could make this somewhat transparent. There we go. Let's do that. Alright, let's try that again. Is this any better? Yeah, I like this better. Okay. These electrons form clouds that surround the 3 nuclei and bind them together in a covalent bond. Switch this back. And essentially what's going on here is that there are, if you count them, there are 8 inside each circle here. And so each element, each atom in there has a full outer shell, but it's sharing this outer shell with another nucleus. And that sharing is what binds the atoms together in a covalent bond. Another way to draw this is simply to just use a dash for each pair of shared electrons. So we can draw CO2 like this as well. There's another way that carbon and oxygen can share electrons, and it actually looks like this. They share 3 electron pairs like this, leaving an unpaired out here and an unpaired out here. Now we have an electron cloud that surrounds the oxygen like that, and the carbon like that. And if you count them up, each circle has 8 electrons inside of it. This is carbon monoxide. CO, and you can also write it like this. So here are space-filling models of the CO2 and the CO. So let's just kind of run through this. First of all, these are both molecules. Molecules are connected by covalent bonds. And the formulas that we see are called molecular formulas. Now recall with this guy up here, this was our ionic crystal, which was made up of millions and millions of atoms stacked together to form a salt crystal, for example. With molecules like CO and CO2, they do honestly stand alone, and in both these cases are gases. With water, H2O, which looks something like this, at normal temperatures and pressures it can be a liquid, a gas, and if you cool it enough it becomes a solid. But they do tend to stand alone and don't connect as easily to their neighbors like our ions do up here. And that's why these are molecules. It is not proper to call sodium chloride a molecule. It's an ionic crystal with an empirical formula, whereas these molecules have molecular formulas. Thanks for watching.